Before we get into the method itself, subscribe to FarmLab, because this technique sits at the crossroads of ancient land management, early agricultural science, and modern soil biology. It's one of the few non-chemical ways to reset diseased or pest-loaded soil without poisoning what comes next. Gardeners talk endlessly about soil health, but very few understand how past farmers deliberately wiped the slate clean when land turned against them. This is that method, stripped of hype and explained properly. Why ancient farmers trusted the sun more than substances. Long before fumigants, copper sprays or sterilizing powders, farmers relied on solar heat to control soil-borne problems. In hot regions of the Middle East, Mediterranean, Asia and parts of Africa, growers noticed something critical. Ground left bare under intense sun didn't just dry out, it changed. Weeds failed, pests vanished, disease pressure dropped sharply in the following season. This wasn't coincidence. It was thermal control applied with precision. What soil solarization actually does beneath the surface. The so-called sun-baked earth trick works by trapping solar radiation in the soil until temperatures rise high enough to disrupt pathogens, insect larvae, weed seeds, and harmful fungi. When soil temperatures exceed roughly 45 to 60 degrees Celsius in the top layers, cellular structures in many pests and disease organisms collapse. Proteins denature. Reproductive cycles break. This isn't burning the soil, it's controlled biological interruption. Why this method sterilizes selectively instead of destroying everything? One of the biggest myths is that solarization kills all soil life. It doesn't. Beneficial organisms adapted to heat survive deeper in the soil or recolonize quickly afterward. Harmful organisms that rely on shallow, cool conditions take the hit first. This selective pressure is why ancient farmers could reuse land year after year without chemical escalation. Now then, let's talk about how the sun-baked method is actually applied in modern gardens. The process, well, it really starts with preparation. You see, the soil must be cleared of surface debris and broken up lightly, just so the heat can penetrate evenly. Moisture, I must say, is absolutely critical. Damp soil conducts heat far better than dry ground, you know. So, after watering deeply, the soil is covered tightly with a clear material, one that allows sunlight in, but traps the heat below. Historically, farmers would use stretched animal skins, oiled cloth, or even glass fragments for this very purpose. But today, clear plastic performs the same role, only far more efficiently. Now, timing really does determine success or failure with this technique. Solarization only works when sunlight intensity is high and the days are long. Ancient calendars mattered for a reason, after all. This method is most effective during peak summer, when solar input is, well, simply relentless. Trying to apply it during weak sunlight, honestly, just wastes time. The soil must stay covered for several weeks, not just days, to allow lethal temperatures to reach a consistent depth. So, what problems does this method solve better than chemicals? Well, soil-borne fungal diseases like damping off, wilt pathogens, nematodes, and aggressive weed seed banks respond extremely well to solar heat. Chemical treatments, you see, often suppress symptoms temporarily, while leaving dormant stages intact. Solarization, on the other hand, interrupts entire life cycles. That's why growers using this method often see clean beds for multiple seasons afterward. Now, you might be wondering, why was this technique used only sparingly and not all the time? Well, ancient farmers didn't go about solarizing everything in sight. Instead, they used it quite strategically, especially when the soil became unproductive or, disease-ridden. See, if you overuse solarization, it can actually strip away the competitive advantage from beneficial organisms, at least for a while. The whole point here isn't to create permanent sterility, but rather to give the soil a bit of a reset. After treatment, the land was typically rested for a short period, or perhaps amended with organic matter, just to encourage recolonization by those helpful microbes. So, how do you reawaken soil life after sun sterilization? Well, once the covering is removed, the soil is biologically quiet, but it's not dead. This is the perfect moment to add compost, leaf mould, or even diluted compost teas. These inputs, you see, repopulate the soil rather quickly with beneficial organisms, while pathogens remain suppressed. Ancient systems, by the way, relied on flood irrigation, manure, or plant residue to achieve the same effect naturally. Now, why do weeds fail so dramatically after this treatment? Most weed seeds actually sit in the top few inches of soil, and solarization targets exactly that zone. Seeds may sprout under the cover, but, they die before emerging, exhausting themselves in the process. This reduces weed pressure without disturbing the deeper soil layers, where structure and minerals remain intact. And why does this method still beat modern sterilants in survival systems? Well, chemical soil sterilants rely on supply chains, protective gear, and repeated application. Sun-based sterilization, on the other hand, relies on nothing but timing, water, and discipline. In low-input or long-term resilience planning, that difference truly matters. The sun, unlike chemicals, simply doesn't run out. So, why does misunderstanding this technique cause most failures? Many gardeners rush the process, skip moisture, or, unfortunately, remove covers too early. Others solarize in partial shade and then blame the method when results disappoint. Ancient growers, in contrast, respected conditions and patience. When those are ignored, the method just loses its edge. And why isn't this about killing soil, but reclaiming it? The sun-baked earth trick is not anti-life, it's anti-chaos. It gives growers a chance to interrupt runaway disease cycles and restore balance, all without poisoning the ground for years to come. That's why it survived centuries of use before industrial inputs ever existed. If this guide has sharpened how you think about soil control and land recovery, I'd encourage you to subscribe to FarmLab. Share this with growers still reaching for chemicals first, and help keep proven low-tech agricultural knowledge alive where modern shortcuts keep failing.